Hello, I'm Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is going to take a look at text files and binary files using the C++ programming language. So this should be, at least at this point of my lecture series, the text file part should be a review, and the binary file stuff should be brand new. So if you need to, I don't have videos for the text files just yet, but I will over my summer, so by the time you read this in my future, you may already have these videos available to you if you'd like to fall back on them. But here I have just a plain old main function, nothing going on. I've included fstream, iostream, the two include files I need to print things out to the screen and to the file. So I'm just going to create just something like this. I'm just going to create a bunch of, I'm going to create 3 vectors. A vector of integers. I guess I'll need to include vector at the same time. Right? I didn't think that far ahead. Maybe I can use an array, but no, arrays are old school, right? So I'll use an array of integer or vector of integers, and I'll just say hours. And this is, I'm just going to do like a pay scale thing where hours worked. I'll just treat it like an integer, and then I'll have pay rate, which will be like a double. And then I'll just to store data inside of these files, just to kind of get something out into the ether here. So I'm going to I'll just set up 5 elements to this thing. That work 5 hours, 10, 22, 15, and 40. Something, I'm just making up numbers. And then I'm going to create a vector of doubles. And then we'll just call that their pay. And I'm just, whatever. I'm just going to make up numbers. 11, 13, 12, 50. I need comma separated, of course. What language am I doing here? I don't know anymore. And then, 17 and 16, 25. Just making up some numbers here. And okay, they're all doubles. So my hours and my pay. It's all fair enough, and they're 5. Each one of these is 5 sides, so just to keep that in mind too as I'm going ahead and doing this. And again, I'm just hard coding stuff just to get the point across here. So there, and so what I'm going to do is I'm going to put this information into the text file, and I'm also going to I can generate their net, or is it net or gross? I can never remember what's what. Their pay from, so this person should get $55, this person should get 130, and so forth and so on. And I can put that into the file as well, but I don't need to generate a vector of it, since I can do that through just using multiplication. So I can open a file, and I can say this is an output file stream, and I'll say I'll call it out, and I'll just say, okay, my file is going to be called data.txt. I like to use txt for this stuff, just because then you're not fighting Windows to open the thing up, so you can actually see it in Notepad or whatever, some kind of system other than just Windows screaming out, "What do you want me to open this with?" and just gets crazy. So txt is a way around all that. All right, and then just if I open it, I got to close it. And then I always say there's a 4-step process to this. You have to be able to open it, you have to use it, and you have to close it. Those are the big 3, of course, right? Open, use, and close. And then you have to make sure that the file opened correctly. So good, bad, and fail. So if this thing failed, then something should occur, right? I should probably exit the program, print out something that went horribly, horribly wrong. Basically thinking like throwing your exception or something like that. And then otherwise, I will do something, and then I can still close a file even if it's a null file. So I can just do if else. I'm just going to put everything else. You could just have it exit the program, but I'd rather have the file close out, then do the system pause or return to 0. So if I run this in its current state, nothing happens. It's a lot harder to get an output file to break to show this is true than it is to get an input. So I can more easily show that this is working on the inside than I can on the out. Okay, but if I get to here, file opened correctly, and I'm ready to go. Okay, so what I can do here is I'm just going to use a for loop for int I equals 1, I is less than equal to 5. I don't need this for anything, or maybe, do you want me to? I guess I could do that where I give them an ID number just based on just the randomness of 1, 2, 3, 4, 5, which element they are in these vectors. And so I have this ready to go. So what I can do here is I can say the file is open, it's called out. And if you know how to use cout, you know how to use, and you know how to do cin, you know how to do input and output from these files. So instead of cout, I just pop that information into out. And I can use iomanip, the iomanip include. I can do all this to set with, and just any formatting I can do to the monitor, do to my screen, I can also do to a file. I'm not going to. This is just beside the point of what we're doing today, but just to show you that I can. So I can print out I can put a space. What I usually do, I'll put an I. Yeah, I'll put a space up front because, well, I'll show you what happens if you put a space at the end. So I'll put an I in there, put a space in there, then I'll put the hours, then I'll put a space in there, then I'll put the pay, then I'll put a space in there, and then I'll put hours times pay. And then I'll put an endline character. I'll just put a space. You can put everything. In the real world, when you're dealing with data, there's no reason to keep it all, one line per record. So you can just go ahead and do this. What did I do wrong though? Oh, hours. Sorry, duh. I'm using vectors. Hours I, pays I, and I'm brute forcing this thing. I'm hard coding this thing on purpose. It goes against some of my normal principles, but that's the way it goes. Oh, look at that. Poke my eye out with a semicolon. Okay, so what will that do? It'll print out all 5 values. We'll see if it does or not. So let's see. Uh-oh. First off, something went wrong. Where did it go wrong? I have a debug assertion fail. Vector subscript out of range. Yep. And that's because I changed my thought process in midstream here, and I said, let's go from 1 to 5, and there's no 5th element in any of these vectors. So if I want to do this correctly, oh boy, right? So, I guess, yeah, so from 0 less than 5, I would have to go ahead here and say, give me I plus 1, because I want the element to be numbers 1, 2, 3, 4, and 5. And then now in this case, yeah, everything else works out appropriately because it is element 0 that's going to be associated with values of 1. So everything's going to be counting by 0 as a computer does versus counting by 1 as a human does. So I think this will cover my previous mistake. So I have no problem showing you mistakes. Mistakes happen all the time. So let's see. And so nothing went wrong, but you're like, well, did my file work appropriately? That's a major big question, right? So let's take a look to see if I can find my file. Okay, so I opened up my data.txt file. I opened it up in Visual Studio here, and so you can see that everything seems to come out correctly. I have 1 for my ID number for employee 1, 5 hours 11, and then just 5 times 11 multiplied with another space, another this, another that, and everything works out. So let's, the math gets a little wonky for me. 40 to 640 plus 6, what is it, 650? Yeah, 650. 40 for employee 5, 40 hours, 16 and a quarter, $650. Everything is space separated. There needs to be a delimiter here so that when we do this with a text file, we know that one number has ended, or one token has ended, and another token is beginning. And so there is an empty space. There's one space after that 650, and we'll see that probably most likely will cause an issue here in a minute when it comes to pulling this file back in and pulling the information back in and doing things with this information. So let's go ahead and do that. So now we have all of this working for us, and now it's just a matter of bringing everything back. So since this is just my demo, I can go ahead and destroy all this since my text, well, no, I don't want to destroy it just yet. I'll comment it out. And because we'll need to go back and fix this up in a minute anyway. So let me go. How do I comment this? I'll just do this like this. And do this like that. So there we go. Okay, so now I'm going to continue to use these vectors, but I'm going to use the clear, hours.clear, pay.clear. Okay, and then I'm also going to set up just vectors for the two things that I've already, the two other records or attributes or fields that I did not include previous. So I'm going to set up a vector of ints for ID numbers, and I'm also going to set up a vector of double for their weekly pay. So the other one was like a pay rate. And this was, so maybe I can change it to just rate here if I remember, and just have it so that's a pay. Instead of pay, make this rate, ray. So I can make this pay down here just because I don't want to complicate things too much. Rate. So how much am I going to actually pay? Okay, so fixing that up, rate, hours, rate, ID, and pay. So now coming back in, it's the same exact kind of, almost the same exact kind of stuff here. So in a way, I can steal what I've already done, and just, I got to make sure I change this to an input file string. So right there, boom, input file string. And on this time, I'll call it in. But if there was a failure, something terribly wrong happened. And let me just comment this out for a brief moment and just make sure in gets closed. And so again, I talked about this 5 minutes ago or so, that it's a lot easier for me to show you just by creating a name that doesn't exist, that something horrible will happen. Horribly wrong thing happened. And that's right, because the file does not exist, because it's data.txt, not data2.txt. So I run it again, and now nothing, that did not print out because my file is open and it's not, it's not, the file was there. It's not a null. Okay, so now coming back to this thing here, so I can set this up so I can kind of read in everything. And once you've read in the, once you've read the information in from a file, you can treat the variables where the data comes from like anything else. It's just the tricky part comes from getting the data. And at a certain point, this isn't programming anymore. This is architecture and design, right? Because there's no way, if I didn't tell you, or if you didn't know what these data values represented, what would you gather from this? You would have to do reverse engineering on this to figure out what the heck's going on. There's a number that seems to be increasing by 1 every so often, but then all these other numbers, and then maybe you could gather that this number is this times this every time. Like, who knows, right? So it's tricky. This is design. You need to know what the format of the data is. And so, like for this, getting the data in is like a reverse here. And so what I need is, I need an integer. I'll say integer for my, I'll just use all caps for these variables coming in. I have an identification number coming in. I have hours. I have a double for rate. And I have a double for the pay. All 4 of these things are coming for each individual record, right? And then 4 items per. And so I can say my in file, put that information into ID. Put that information into hours, put that information into rate, and put that information into pay. And so I can chain this together, and this, again, the space is the delimiter, so it'll run the, and go, oh, hey, I found a 1, and it'll put that into ID as an integer. And then when it hits the space, it'll move on to the next, and it'll give me 5, and then the 11, then the 55. And since I have everything set up with the correct data types, it'll convert appropriately. It'll parse the data appropriately. So my final step here would be to do a cout and just go, okay, cout the ID number, and just to print things out, right? Just to see. I'm not, you could add formatting. Oops, I am not worried about any of that. I'm just showing you the basics here. And then so rate, another space, and then pay, and then I will do an end line, so I can print out 1 per line. And so what does that get me? What does this do for me after all of this? You can see, oh goodness, okay, 1, 2, 3, 4, 5, and it printed everything else. It printed everything out correctly. So for me, interestingly enough, it didn't do anything wrong when it comes to, but why didn't it do anything wrong? And why didn't it do anything wrong is because I kind of hard-coded this thing for 5 elements. And in general terms, that's not allowed, right? Think of like a credit card, like at the end of the night when a company is trying to resolve all the credit card transactions for the day. are you going to hard code just 5 elements? That file could have 0 elements in it. It could have 5. It could have 100. It could have 1,000, right? It could have any number of elements in it. But I've specifically hard coded this thing because I copy pasted the code and just kind of haphazardly did it. But I'm like, and everything seemed to turn out perfectly right. But I warned you, it's not going to. That one extra space is going to ruin a little bit of what we do. So instead of this kind of a for loop, I can use a while, and then I could say my file again is called in. And then there's a function called EOF, which stands for end of file. And so what this does is basically says while the file has not reached the end, because there's a special character right at the end of the file that screams out, hey, I am done, the file is complete. And so unless I reach that, I do this whole thing one more time. And the whole, in this case, I'm just presuming that I know that there's 4 elements. In a real world example, you would probably error check every step of the way to make sure this thing is working. So now if I run this one more time, there we go. There's everything that's wrong with this thing. And you could see that one space ruined everything. For whatever it did, it basically, because that space is part of the file, and it's not considered the end of the file. Even though it's white space, it's considered part of the file. I haven't reached the end of file. It goes through one more time through my iteration, and basically the last iteration here is complete garbage. I mean, it just seems like it's this record, but in essence, it really truly is garbage because it doesn't belong. There's only one element, there's only one record in here that has a 5. And again, that just comes back to the way we set this up over here on the input or the output side. And you just have to make sure that there's no extra space at the end. And so when I do these kind of things, I usually set up the space in the front and not the back, because the parser is never going to notice that space when it comes to text files, at least up front, because that space will be part of the one as it's generating to figure out what to print out for the ID number. But then when it gets to the end, it prints out the pay rate, but it then does not print out any other characters past that. So when you put the space up front and I run this together now, you can see that I only get the 5 records like I'm supposed to. 5 records go out to file, and here are the 5 records that go out to file, and then five elements come in, because I'm using the while loop here. I'm using a for statement here, but when I'm pulling this thing out of the file, I'm doing a while loop. And so just to say here, if I made this, just say hours.size instead, and if I wanted to now, this is much more flexible. I can say, okay, this person worked like a doctor for a week here, they got 80 hours, and but they made I don't know, $14 an hour, and now this thing's a little more flexible because this thing is tied, instead of being hard coded, this thing's tied to the size of this vector, and then this code is tied to the file itself. So all I have to do now to add records to this thing is just add to the vectors at what you see over there. And as you can see now, employee 6, the one we just created, 80 hours, $14 an hour, they make $11.20 gross or net for the week. And at the end of the day, that is all there is to it. I mean, if you know how cout and cin works, it's just a matter of piping the thing to a different stream. Instead of printing to screen, you're printing to file. And the same thing goes on the input. Instead of outputting or inputting, I say, what am I doing? I'm inputting 2 variables from the file, exactly like I would do a cin, right? I mean, if this was cin instead of cout, it would just be a cursor waiting for me to type values, and then those values would go into those places. But it's replacing my input with data that's stored in the file. Okay, so that covers the idea of doing this with the idea of text files. So now let's go ahead and do this one more time with the idea of binary files instead. So binary files take a little getting used to, and you kind of have to think at a lower level than you really do for a lot of other stuff that you do. Those of you in my assembly language classes, or those of you who watch some of the assembly language videos, you kind of have a better understanding of what's happening down below under the hood. And so I'm going to start with this file here located at this website, binary files with C++ RA4, and this is pretty good, except I can never get it to work in Visual Studio. I have to tinker with it. I have to make it a lot more explicit. You'll see here in a second, like the code here for opening the file, that's going to stay the same. Normally, we just pass in one parameter when it comes to this open function, or if the way you put it in is a parameter, as the parameter to the constructor. But there's a second parameter that basically is setting, I want to set it in binary mode, and in this case, I want to set it to input mode. And I'm just going to say, for our case, we're going to write out to the file first. So I'm going to say binary and out. So you can imagine it's just iOS : out. And so that's going to be the same, but writing to a binary file here, you're going to see this is essentially what we're going to do. This just throws everything for a loop. Maybe your understanding of computer science when it comes to just data in general. And so what this line of code says, let me see if I can make this a little bigger. There we go. What this line of code says here, write to my file. And then it says, okay, now you say address of x comma size of int. And you're like, oh my goodness, in the past when we just did text files, we had to have, we put no thought into the process of how many bytes we're going to write out and how we're going to do it. We just did it. We just said, just print it, and the computer just did it. And now this has to say, you have to say, give me a memory address, and then tell me how many bytes starting in that memory address do I want to go. And so every program that is ever, that ever executes on a computer is sitting in RAM. And so when you think of everything, all of the code, like all of the literal code that goes into the commands and the operations the computer is performing, is sitting in RAM. All your global variables are sitting in RAM. All your local variables are sitting in RAM. Just memory. And so if you think of, and memory is just, think of it as visually as just one completely humongously long street. And every single byte along the way has a memory address, has an address associated with it, and something could potentially be stored there. And so in this case, x is just some variable sitting, and the way this is, it's sitting in my call stack because it's in my runtime stack. It's not a global variable. So, but what I'm saying is find that memory address and for x and just go, okay, that's where I want to start from. And size of int, that's 4 bytes on our architecture, but it's not guaranteed, right? Every computer might have a different architecture, or maybe this program running 40 years in the future will be running on a much different processor where int is a larger size or even a smaller size, who knows? And so this is just saying, okay, start from memory location x, wherever x is located in memory, where my variable is stored, and print out all 4 bytes of that data to the file. And so the same thing goes below. Take whatever fx is. Now this is a double, and we're going to be using double as well. It says, well, find that memory address where that variable is stored and print me out all 8 bytes. In this case, in our environment, a double is 8. Pretty much across the board, double is defined as 8. Integers are different, but floating point is the IEEE 754 standard. And then so size of, so it'll print out all 8 bytes to the file. And I don't need any spacing between it because before I needed to know when one text ended, one variable ended and another began. But now when I come back to this, I'm going to know, hey, the first 4 bytes are reserved for this int, the next 8 are for the double, and so forth and so on. So I don't need any extra space padding when it comes to what I'm doing. And so it's just over and over and over again doing that and then closing out. So that's the idea. And now that you know that, let's look at the code and you go, oh my goodness, what did I do? If you know a better way, please let me know, because this is the only way I know to go about doing things. So we're using the same data as before. I'm using the same output file as before, and I'm also going ahead and setting up with binary and out mode like we're discussing. That's a pipe, that's an OR, that's a bitwise OR operation, so I can add the two things together here, so I can be binary and out at the same time. I'm using the same fail test, and then now I'm using the same for loop, but now as we just discussed here, now that I have this out, I can't use those arrow operators like I could before, and now I have to use the write function. So now screaming at reinterpret cast, right? So because that code that I saw will not work on my box right here. And so reinterpret cast should scare the holy heck out of you, and it generally should, right? It should, and it does. And so all I was doing, like notice here, this is how we would have done things on that PowerPoint or on that HTML document. I would have passed along the memory address of I, the size of int, to print out the ID value, which is just the 1. And so in the process of doing this, the compiler, what does it say if I don't do things this way? where is my error list? Come on, error list, down here somewhere. And so it says that int pointer is not compatible with const char pointer, because we're discussing, like, we're dealing at raw memory now. This is not integer, double, float. We're just discussing, this is binary mode. This is raw memory. So it's like the idea of a type does no longer matters. So what I can do here, since this I is an integer type, address of I is basically a reference or a pointer to an int. What I have to do is say, okay, I know this was supposed to be a memory address as an int, but let me, oh geez, where did it go? Oh, let me undo. So there we go. So let me reinterpret this and just basically say, okay, you were an integer pointer a second ago, but no longer. Now you're a character pointer. And so now I can go, now it completely changes things. So instead of thinking things as an integer, thinks of things as a character. So now I can print out 4 characters, because it's as character for character, it will just go through my memory, character for character, and spit it out and just go, here's 4 bytes, put into the file. And down below here, again, here's another integer. It's just reinterpret, reinterpret, reinterpret. The only thing you don't have to, I guess, is characters, but we're not using those. So get me the address of the I-1 element of the hours vector, which is the 5. Spit that into the file, 4 bytes. And then the other 2 here are, the address of rate -1, which is in double form, right? Because this is a double vector. So that element needs to get shot, all 8 bytes of it, to the file. And then here's where another fun little thing is, it has to be a referenceable memory address. It can't be an immediate value that you could pass along, because it has to be a memory address, because it has to be something in my RAM that I can go ahead and just blit out all the data. So I have to go ahead and set up my pay from the calculation, hours times rate, ahead of time, so it has a legitimate hard-coded place in my RAM, in my call stack, so I can give it the memory address, so I can call the function on this with the size of double. I cannot just go ahead and put like this, reinterpret this into that. It just does not work. See, it already throws up a fit and invalid type conversion. Good luck if you, like I say, some of these error messages are like, can you help me a little more? Because that one could use a lot more help, especially when we're dealing with such a complicated topic such as this. So now, at least this is on the output side to file. Everything seemed to have worked. Did it work? That's a big question. So let's see here, hash mail, and come back to this. Nope, not that one. Yep, this one. And so now I just, beforehand, I pulled in the file, and I used a website to take the binary file and convert it into hex. So at least we can kind of see what's happening on a byte for byte basis. And so in these cases, what do you see here? The first 4 bytes are 1000, then the next bytes are 5000, and then there's a whole ton more. And then you're asking yourself, is this correct? Because why would the 1 be first? Why would the 1 be the first byte, not the 4th byte? And again, coming back to those of you who have taken assembly language, or those of you who understand the concept of endianness, this totally makes sense to you. We are working on a low endian machine, a small endian machine. So the bytes are put into the file, or the bytes are just put into memory in reverse byte order. So this is actually perfectly legitimate. You read the bytes in reverse, and so the 1 actually goes up front, and this is actually a 1. 4 bytes of storage, this is the 1, which is the ID number. And then here is the 5 hours that the person worked in hex, in the 4 numbers. And then I'm not expecting you guys to know that these 8 bytes here make up a double, and like, well, how would you represent that? There is a pretty simple way to take this value and represent it, because it has to be represented in binary, but what does it represent in decimal? And I can guarantee it's right, and the same with the next 8 bytes. But then now moving on, here's the second element, right immediately after. There's my 2, there's my 10, A is 10, right, in hex, and so forth and so on. So there's 120 bytes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 times 6, 32, 64, 9. Yep, so it comes out, well, whatever. There's 120 bytes here, because there's 8 plus 8 plus 4 plus 4, which is 24 bytes per record times 5 records, gets me 120 bytes. So this file is now good completely unreadable. Coming back to this, this is what it looks like in binary mode, because there's no characters that we can represent, because they're not ASCII characters, they're just pure binary values sitting in a file. If you've ever opened like a docx file or an Excel worksheet in Word or anything like that, or like something that just shows you the raw data, you know what this looks like, and that's the telltale sign of binary right there. Okay, so this is how you would do things when I'm writing out to a file. So let's take a look now at bringing this file back in so we can print everything out. So I've just gone ahead and written the code then for the input from the text file. The text file, or so the binary file. The binary file again has 120 bytes associated with it, 24 bytes per record. 4488. So now it's just a matter of bringing them back in. So if Reinterpret Cast didn't scare you before, it shouldn't scare you now, because it's the same idea just in reverse. So what do I have? I have an IF stream for input file stream, input in data.txt, binary in, same fail call here. Otherwise, let's do some stuff. So while the end of file is not reached, I have the variables that I need to put, because they're RAM again. I have to find some specific place in RAM to put data. So I say, okay, Reinterpret Cast, this was an integer pointer, because again, it's just memory. It's just a memory address that I'm repurposing and just saying, okay, C++ is forcing me to treat it like an integer, but I want to treat it like a character, and so I can just go ahead and do this. It only works for pointers and references. So then I can say, okay, this pointer, treat it like a raw pointer now, treat it like a raw character pointer, and get me the first 4 bytes out of that file, put it into that variable. So everything will go back in the right order. We showed a minute ago, everything got put into reverse order with the little endianness, but everything's going to come back just fine. And so the ID comes back 4 bytes. The next 4 bytes is ours. And again, we have to know this. There's no other way we would know this if we didn't have understanding of what the format of the file is. So then integer value for hours, double value for rate, double value for pay, and then print everything out. And then close the file when the loop completes. So again, everything works except all of this stuff I was telling you about, this duplicate stuff at the end here. Look at this. Even though there's no extra byte, there's exactly 120 bytes in this file, I promise you that it still goes ahead and does the second record 2 times. I'm sorry, the last record 2 times. And so you can see there's 2 6s, even though there shouldn't be, right? I mean, it's not like I put it in here in duplicate. So that is a bad thing, right? Because you don't want to be that credit card record that gets double billed or something like that, right? Just because you happen to be the last one of the day. And so, C++ is fun in this regard, where just that one extra little something at the end causes issues. There's all tiny little things, a lot of little things that other programming languages have resolved over the past. So coming down to it here, I just went to Stack Overflow, and you're like, okay, how can I get around this, since I don't do this every day? File input, binary file input is not something I do every day. And the gurus over at Stack Overflow basically said, for binary at least, don't use EOF. Like, okay, so what do I do instead? And they're basically saying, well, put the read into the function, or into the conditional part of the while loop. And so because coming back down, the read function returns, what does it return? It returns a stream, but it will return basically a null stream if something went wrong. That's just kind of what I'm getting out of this. And so what it's telling me to do is just take the initial read here, because the first item I would ever search for is when I'm in the file, like, give me the identification number. So this would go here. I don't know if I need as many parentheses around everything, but then this will give me an error, because of course it doesn't know what ID is, because ID has not been defined yet. So it's one of those things, either you can put everything up, it's whatever you feel comfortable with, or just bring the ID up in front. These are pseudo temporary variables anyway. We're only using these to hold the values as they come in from the file. And again, I don't necessarily like this idea of having one read inside of the while and all the others, like the conditional versus the body of the thing. It just reads a little sloppy. But at the end of the day, what happens when I run this is I get the result that I'm looking for. Only the 6 records. I do not get a duplicate record for the final record. And just to try it out here, I could try this out one more time. 11 hours, $19 an hour. And there's my 7th record, 19 with the 209, like I'm expecting to see, with no duplication of any of the records. So they say it's already complicated enough, so it's just what's that one little thing to keep on, to catch on the end there. I was very surprised to see that in binary mode, because there's no extra byte, but it still somehow does not read the end file exactly like it should. And so it's all fixed now. And so now you have an understanding of how to do binary files. So that's pretty much it. We've talked about text files, we've talked about binary files, and now it's just taking this idea and just running with it, right? Like, you can take in any data type. You can take and you can print it out, you can bring it in. And so, and in binary mode, you don't have to worry about formatting like you do in text mode. Text mode, you can make it look nice, you can print it out as a as a full PDF, basically, just print it out with that nice formatting. But in binary mode, we don't care. We're trying to compress this thing as small as possible and get the job done. So as always, swardb@cod.edu is a great way of getting a hold of me if I made a boo-boo here, or if you just want to send a comment or something like that, have questions about my videos. Otherwise, you can also send a comment here on YouTube. And so thanks for putting up with me. I think this is a pretty good video. Let me know if it's not, and we'll see you around. See you in other videos. Thanks, everybody. Have a good one.